Welcome to the URL phase how-to series video. In this video we will show you how to create a Tesla settings file. To begin, we will need to create an ID configuration. This is done by selecting Add New. In here we'll give it a name. Select your configuration. If you have PMU module, make sure that you put that in here. You can enter in your network information, your IP address. In the folder placement, you'll see the recordings. This is the default folder where it'll store all your recordings, and the configurations. This is where it'll store all your configurations. You can also go ahead and modify this as you need. Last step in this is to save the ID configuration. To create a settings, come into settings, select new. This is where we can select the firmware version associated with our Tesla. On the main screen here, we can also do the same thing here with the versions. We can set up our sampling rates. This will also determine what our highest harmonic value recorded will be as well. In the element tree, we're going to build out our channels. We're going to select it and then right click on it. We're going to add an element. This will be the reference name that will be used throughout the programming and for records and for all data retrieved from the Tesla. Click away. We're going to right click again, and now we're going to add our parameters that are listed here. Let's begin first of all with the analog inputs. We'll start with the voltage. Here we can see what the type is. We can put a description in. The channel is the physical analog input connection on the back of the Tesla. We can select our module types. The view set scale is for setting the scaling. Here we can set the primary, the units, and the nominal secondary values. The angle offset, this is used for calibrating the PMUs. The rate of change cycle interval is used for the rate of change monitoring. We have a single harmonic that we can also monitor, and the nominal level here is associated with the sag and swell. All of these are different trigger levels where we can set up trigger limits, put in a delay, and enable allows us to enable the action. We can select it either to be recorded as a fault record once this threshold is exceeded, or a swing. A log is automatically recorded once this threshold is exceeded. We will then go in. The next thing is the notify. This is used in conjunction with the record-based central station, that if we exceed this particular threshold, it will be recorded. The cross trigger is used for our co-op mode, where if we're using a manual connection, this will go ahead and energize that particular contact associated with the cross trigger. The alarm contacts can be assigned to whatever threshold. You can see 1 and 4 are missing. 1 is for the relay health, and number 4 is associated with the cross trigger. The priority is used for the record-based central station. You can assign a specific priority to notify the record-based central station application. Next, let's come back to the analog input. Let's right click again. Let's add our currents. Same type of idea. We can select the type and our input connection on the back of the Tesla on the analog inputs, and our module types. Our scaling for the CTs. I'll put in 1005. Once again, we can indicate whether we want to record a fault or a swing, or what other actions we want to assign to this. If I put in a magnitude of, say, 5.5, this is a secondary value. If we select primary units, this will show me the equivalent in the primary. Now, the other thing that we can also do is we can also go into the high level parameter and take a look at this, and it'll give us a summary of the configuration. So this way we can verify that everything has been set up properly. Here we can see that the scaling is not the same. And then we can go back and modify that. Anything that's grayed out has to be done from the actual screen. Anything that is white, we can actually go in and modify from the screen here. So go back to phase B. And the same thing with phase C. To add an external input, we can right click again, select new external input. We can come in here, give it a description. Put a delay. We can change the labeling here if it's active. And the same thing with the inactive state. If we want to monitor this in the records, we can also go ahead and enable this and select our different types of records. Let's add another input. Right click again. External input. Give it a new label. Next, let's add our sequences. This will allow us to go ahead and monitor our positive, negative, and zero sequences. We'll have to assign the voltage inputs that we're going to be using. Once again, here we can set up different thresholds, trigger levels, and also to be recorded. Let's do the same thing with the currents. Go back in, right click, sequence, do the same thing for the currents. The sequences will also be used for the power. So let's go ahead and create the power element. So we'll right click, come down to watts and bars, and we'll assign our voltage inputs, V sequence and I sequence. Once again, here we have different triggers that we can select, set up their limits, delays, and how we want to record them. Let's take a look at another item. Let's look at the frequency. We'll have to indicate here what we're going to use for a reference. In this case, we're going to use VA. And once again, magnitudes and rate of change. We can set up our thresholds, delays, and how we want to record them. Now, let's say we want to look at the neutral current. What we can do here is we can go in and add through the analog inputs, going down to neutral current. This will be a measured neutral, where you would go in and set up your primary and secondaries for that particular current transformer and the module type that you're using. If we want to do a calculated neutral, the way we would do this is by going into summations, right click, and we would go into summation. hit assign our inputs for that. IA, IB, and IC. And this calculated version is basically the vectorial summation of IA, IB, IC. You don't need to change the scale factor or the offsets. Once again, you can set this up with thresholds to trigger a record. Next, let's take a look at the metering groups. To create a metering group, we'll right click on our metering group, select new, and in here we can pick and choose which parameters we would like to assign. I'll just pick a few so you can see what they look like. Add a little spacing in between the different types of signals so that you can monitor them. They're a little easier to see if you put a little bit of space in between. Our sequences. Here we have our positive, negative, and zero sequence components, both for voltage and for current. Our power components, and the frequency. One more thing, we'll just go ahead and we'll change the name. When you right click on it, once again, we can come in here and change the name. And let's go ahead and save this. It'll give it a default name. You can change this to whatever you want. Select save. To load this into the Tesla, first we'll have to close this and connect to it. Here we have three choices for view, change, and service. I'll select change. Now that we're connected, we can come back to the settings screen and select load to IED. This created an error because I have an older Tesla. I need to go back and change the configuration. You can double click on this, and on the main screen, under identification, come back in, change it to the firmware version in your Tesla, select OK. Before we install this setting into the Tesla, let me just show you what the channel tree represents. So if we open up the channel tree, when we expand on, these are all the different parameters that are available inside the Tesla. This will show you your connection points. So under analog inputs, this device has 36 analog inputs. I can see what each one of the analog inputs are assigned to. Same thing with the external inputs. I can see which ones are connected and what their labeling is. Sequence components, and the rest. Now, let's go ahead and close this, and let's go ahead and load this to our Tesla. Now that we're connected, we can come back to the main screen and look at our metering screen. So let me begin with the analogs. This is a standard configuration that's in the Tesla, and you'll just see the analog inputs, their magnitudes and their angles. The digitals, these are the external inputs, all 64 of them, what state they're in, what label they have, and the meter screen that we created with the custom screen and the state. You can see the state of the analog input, or you have the external inputs change states. And there you have it. This concludes our how-to series video on how to create a Tesla settings file. Thank you for watching.